Here's the answer for day one, problem one. Simplify as much as possible. We have the fifth root of 64x to the fifth power. 64 is not a number that you can take a fifth root of and get a whole number result, but 64 does factor into 32 times 2. So that'll be our first step. Let's rewrite this as the fifth root of 32 times 2, and then we'll retain the x to the fifth power. The reason I chose 32 times 2 is because 32 is a number that you can take the fifth root of. 2 to the fifth power is 32. So here we get a 2. Let's also take the fifth power of x to the fifth power. That's x. And then the factor that we did not do anything with yet, we'll leave inside of the root symbol. And don't forget the index here for the fifth root. Day one, problem two. Factor the polynomial. Hint, try grouping method. The reason this hint is here is because this has 4 terms to it. So it's not going to be one of those trinomial patterns. It's not a difference of square pattern or anything like that. And there's not a greatest common factor that will divide into all 4 terms. However, if you group into a couple of binomials and treat these separately, we can find a greatest common factor. So in this first set, we can divide both terms by x squared. X squared times x is the x cubed, and x squared times minus 2 is the negative 2x squared. Now let's look at the next piece over here. This has a leading coefficient that's negative, so when we factor out the GCF, we're going to include a negative with it, negative 3. And then in parentheses, negative 3 times x is the minus 3x, and negative 3 times negative 2 makes the positive 6. Please notice that we have a common factor of x minus 2 in both places of this factored form. That's like having a greatest common factor of x minus 2. So we can factor out the x minus 2, and then in parentheses, fill in these missing parts. X minus 2 times what was that first part there? Well, it was x minus 2 times the x squared. Now over here, x minus 2 times what was this part? Well, it was x minus 2 times negative 3. Before we stop, we want to just look at this factor and make sure it's not a special pattern that goes any further. It almost does. If that had been a 4, then that would have been a difference of squares and we could factor more. But that's not a perfect square number, and so we're done. Here is the factored form of that original 4-term polynomial.